Welcome. Today we are discussing Module 8.1, Evaluating RAG Pipelines with RAGAS Theory. Here is a quick look at where we are in our curriculum. Welcome back, everyone. Today, we are tackling one of the biggest challenges in production AI. How do we actually know if our RAG pipeline is working? In production environments, relying on arbitrary human evaluation, or vibe checks, is a recipe for disaster. If your pipeline accesses thousands of policy documents, manual verification is not only impossible, but it also misses subtle hallucination loops. Traditional translation metrics like BLEU or RAGAS are completely useless here because an LLM can write a perfectly accurate answer using entirely different words than your reference sheet. We need an objective, scalable, and automated mathematical approach. That is where RAGAS, Retrieval-Augmented Generation Assessment, comes into play. Let's look at how we can split this complex problem into verifiable, isolated layers using structured relationships. To understand RAGAS, you must master the fundamental Triad metrics. We do not evaluate the system as a single black box. Instead, we separate the retrieval step from the generation step. Think about it, if the final answer is bad, did the retriever fetch the wrong documents, or did the generator make things up despite having the correct documents? RAGAS solves this by mapping the connections between the query, the retrieved context, and the generated response. Faithfulness measures if the response is strictly derived from the context, detecting hallucinations. Answer relevance measures if the response actually addresses the user's question, penalizing redundant or evasive sentences. On the retrieval side, context precision evaluates if the most relevant information was ranked higher, while context recall verifies if all necessary ground truth facts were successfully retrieved. Check the link in the description to download the architecture diagram and script representing this metric paradigm. How does this look under the hood? It sounds like magic, but it is actually a highly structured form of prompt engineering combined with natural language inference, or NLI. To calculate something like faithfulness, the RAGAS engine sends the generated response to the judge LLM and instructs it to break down the text into atomic, individual statements. Each statement is a single factual claim. Then, in a secondary processing loop, the judge LLM analyzes each of these individual claims against the retrieved context documents to determine if it is directly supported. The final faithfulness score is simply the number of verified claims divided by the total number of claims. By implementing this programmatic flow, we convert qualitative semantic assertions into high-fidelity statistical metrics. Let's look at how this execution workflow is sequentialized programmatically. Now let us translate this theoretical foundation into real, executable Python code. In this script, we initialize a synthetic RAG evaluation dataset containing the query, the retrieved contexts, the model's generated response, and the expected ground truth answers. We import essential metrics directly from the RAGAS library, specifically faithfulness, answer_relevance, context_recall, and context_precision. Using an LLM configuration, typically backed by a robust model like GPT-4o, we trigger the evaluate function. This computes precise scores for each of the specified metrics and formats them into a clean pandas data frame. You must check the link in the description to download this production script and experiment with your own datasets directly. Let us check what the terminal spits out when we execute this code. Whoops! Looks like we've hit a live debugging moment right here on screen. Instead of the clean terminal output we expected, we're seeing a module not found error, no module named datasets. This is a classic dependency issue, indicating that our current Python environment is missing the datasets library, which is crucial for our script. To quickly resolve this, we simply need to run pip install datasets in our terminal. This is a common pitfall in software development, especially when setting up new projects, and a great opportunity to emphasize the importance of managing our Python dependencies. Once installed, our script would have proceeded to compute precise scores for each of our critical metrics. You'd typically see faithfulness, answer relevance, context recall, and context precision being evaluated. In real production tests, however, you will often find fluctuations. If you see a faithfulness score dropping below 0.8, it indicates that the LLM is generating statements not present in the retrieved texts, revealing dangerous hallucinations. If your context recall is low, it means your semantic search vector setup failed to fetch the necessary details. By continuously inspecting these outputs, we gain immediate, actionable feedback on where our pipeline is failing. Now that we understand the deep mathematical theory of RAGAS and how to evaluate runs, how do we operationalize this in an enterprise environment? The answer lies in complete automation via continuous integration pipelines. Imagine a scenario where a software engineer changes the chunk size of the vector store or updates the system prompt. Instead of hoping everything still works, a git push triggers a CI/CD workflow that spins up our evaluation script against a gold standard validation dataset of, say, 100 core test questions. If the computed faithfulness or context recall drops below our high-quality threshold, the build fails automatically, blocking a flawed deployment. Make sure you check the link in the description to download the architecture diagram for this enterprise CI/CD integration. In our next upcoming lecture, Module 8.2, Writing Unit Tests for RAG Accuracy, Practical, I will show you exactly how to write production-grade unit tests using PyTest and RAGAS to prevent regressions dynamically. I will meet you there.